Alright, Trevor, shut that over there. Here we go. Alright, we've got inequalities. Y'all be quiet. Notes open, Chromebooks shut. Inequalities means we're going to have some shading stuff that we're looking at. Okay, so we've got here, let me grab my graph paper I want to use. This first one we're going to look at says y is less than negative x squared minus 2x minus 1. Okay, the directions for this just say to graph. Our directions are going to change throughout this lesson. In a little bit they're going to say solve, but for now just graph. That's all we got. So basically what we're going to do first off is just graph the parabola like it was an equal sign. Just do it like normal. Okay? Been a while since we've graphed one. No. This is in standard form. We know that when we're in standard form, we can start finding our vertex by doing negative b over 2a. That's been a while. Remember that? The x of the vertex is negative b over 2a. So x is going to equal negative. What's our b? Negative 2 over 2 times what's our a? Negative 1. Okay, look at all this. I got negative overload over here. So here's how I read this. A negative divided by that negative is a positive. But then divided by another negative turns it negative. 2 divided by 2 is 1.
What formula is that?
Negative divided by negative is positive. Divided by negative is negative. 2 divided by 2 is 1. Negative 1.
What formula is
it? That's the axis of symmetry. Okay, so x equals negative 1 means I'm going to go to the left 1. And that's where the axis of symmetry of our parabola is going to be. Now, what do I do to find the height on that, the y that goes with it? Good, Stephen. We're going to take that negative 1, Trevor, and we're going to plug it back in over here and solve for y. Okay, so I'm going to have my negative. I'm just still got that negative there. My x is negative 1 minus my x is negative 1 minus 1. Alright, be careful on your signs here. This negative 1 squared is 1, but then it's got a negative out in front, so that turns it back to negative 1. Negative 2 times negative 1 is a positive 2, and then I still got that minus 1.
So why'd you do the square root first? And
I did my squared first because the order of operations says exponents come before multiplication. Negative 1 plus 2 is 1. And 1 minus 1 is 0. So that means that my vertex of this parabola, I got an x of negative 1 and a y of 0. So there is the vertex. Okay, now we got to find another point. What do we do to find another point on our parabola?
Can't you plug that point in that you got?
Not that one. I already.
Quadratic.
No.
You can plug 0.
Okay, I need to just pick some other x to plug in and solve.
Yeah.
So
0, 0.
Well, I can plug a 0 in. I don't know if it'll get a 0 out or not. I can plug a 0 in for the x and see what that makes the y. So you can pick any other x except for the one you've already got. If you pick that one again, you'll keep getting the same answer all the time, right? So Trevor said 0. This is easy because look up here at our original equation. That if I plug a 0 in there, that's 0. That's 0. All that's left is negative 1. So I'm going to go over 0 and down 1. Now to finish that parabola, remember that axis of symmetry is in the middle? So if I have this point that's 1 away, I just need to go 1 away on the other side. Alright, don't draw your parabola yet. Here's where new stuff comes in. All that so far has been old. Here's where new stuff comes in. This didn't say y equals. It says y is less than. Normally we would just draw these with a solid shape, but it's just less than. It's not also equal, so Trevor's right. Our parabola is going to be dashed or dotted. So we're going to connect our parabola with a dashed curve. If it's got the equal line underneath it, it would be a solid curve. If it doesn't, it would just be dashed. You've done that before in Algebra 1, just probably not on a parabola. But you've had dashed, you've had dashed and solid and dashed You've had those lines before. Alright, I told you yesterday that these things were going to involve some shading. Like when you used to have number lines in Algebra 1 and you had to shade when it was greater than or less than. So what we have to do now is pick a test point to figure out if our parabola gets shaded on the inside of it, where my mouse is there, or does it get shaded all on the outside. Okay, so the easiest thing to do, what I suggest, is you pick any test point that's inside the parabola. Right there. That's a good one right there inside the parabola. I just picked that inside the parabola. So that would be -1, -2, right? I went left 1 and down 2 to get to that. So -1, -2. That's my x, that's my y. I'm going to plug that in the equation and see if it's true or not.
So -2 is less than.
Okay, good, Carolyn. -2 is less than -1 squared minus 2 times -1. I didn't save enough room. Let me erase and start writing again. Go up here where we can see it better.
Wait, where'd you get the -2?
No, we chose a point on the inside of the parabola, which she chose -1, -2. -2 y, -1 x, so we're plugging it into y is less than the -x squared minus 2x minus 1.
Sorry, I just went. I'm just doing that.
Once we pick the point inside, now we're just plugging it back in the original problem. Okay, so I've got it set up here. Trevor, I got it set up here. That -1 squared is 1. And then you make it the opposite, so it's -1. So I'm looking up above here at -2
Plus 2 minus
is
1.
less than -1 plus 2 minus 1.
So -2 is less than 0.
So -1 plus 2 is 1. And 1 minus 1 is 0. So what we have says -2 is less than 0.
It's a true statement, so it's inside.
Okay, so we have to decide then if our statement that we ended up with is true or false. And a negative is smaller than 0, so that's true. So that means this test point gets shaded. So inside of my parabola will be the shaded part. If it had been false, we would have shaded all outside. We wouldn't shade our test points.
Yep.
Now the directions on that problem just said graph. Okay, our directions are going to change throughout this lesson. There they just said graph.
I'd like to see my mom today. Alright, that one says y is greater than -x squared minus 2x plus 15. Directions are the same here, we're just graphing. Alright, looking back at the last problem that we did, when we're graphing and it's in standard form, first thing you got to do is start finding your axis of symmetry. What's our formula for finding axis?
X equals -b over 2.
X equals -b over 2.
Okay, so I got negative, what's my b?
-2.
-2 over 2 times, what's my a? Okay, so that's the same, isn't it? My axis of symmetry is again -1.
So plug that in.
Now once we get that, we plug that in our equation to find our min or our max. So we're going to have -1 squared minus 2 times -1 plus 15. So that's -1 plus 2 plus 15.
That'd be 16.
Yes, it would. So our vertex is -1, 16. Okay, I'm fixing to move my axis of symmetry over so I can count on every line. Well, that's still 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, that's not going to
Go
help.
by 2.
Oh, a little fast, that's
Yeah.
right.
We will.
Each block is 4. So
4, 8, 12, 16. That'll work. Alright, so I had to do some creative counting there to be able to find 16 on my graph. So this was 4 going up, 8, 12, 16. Alright, now how do we find another point?
You plug 16 back in? Or
No, don't plug 16 back in. Just pick
Oh,
good, Jody. Just pick some different number to plug in.
I'm glad you understood that, because I could be understanding.
0.
Okay, zeros are easy. If I plug a 0 in for the x, that just takes that out. That's nothing. That's nothing. All that's left is 15. So over 0 and up 15.
And it's got to go on the
It's
opposite
got to be in the
side.
same spot on the other side. You got it, dude. Now, when I draw that parabola, will it be a solid or a dashed curve?
Dash.
Okay.
Yep.
So I'm going to draw that. Dashed. Trevor, I don't know if you're distracting them or not, but you're distracting me.
Wait, why would you ask me?
Because it just has a greater than sign. It's not, doesn't have an equal bar underneath it.
Where?
If the, you see where it says bottom, if it's equal, then it's a straight or
Oh.
line. If it's like less than or greater than, then it's dashed.
Okay, now the first problem that we did was less than. This one's greater than, but our plan of attack is still going to be the same. We got to do a test point. So I like to pick a test point that I'm sure is inside the parabola. So this is -1. How about right there? -1/8. Would that be
Yep.
okay?
That's good.
Okay, so I'm going to plug that into my original problem. -1 is my x, 8 is my y. So I'm going to say 8's greater than -1 squared minus 2 times -1 plus 15. -1 squared is 1, make that negative. So I got 8's greater than -1 plus 2 plus 15. 8's greater than, that's 1 plus 15.
8 is greater than 16.
Alright, so we ended up on our test point with a sentence that says 8 is greater than 16. What do you think about that? No, 8 is not ever greater than 16. This is false. So my test point was false. That means I can't shade my test point. So I can't shade in the center of that parabola, which means my shading would be all around it.
All around.
Who was it? Was it you, Chloe, that got excited about getting to scribble today? Somebody. Oh, must have been in another class. Somebody was excited they got to. I told them we would get to scribble.
That sounds like something I'd do excited about.
It was gay.
Jesse will.
Alright, now what we're fixing to add on, we're going to have the same. We're going to have the same deal. We're going to have an inequality to graph, but there's going to be 2 of them. So we're going to have to graph one, shade it, graph another one, shade it, and then our answer is going to be where our shadings overlap.
Come in.
Wait, why did you
I've
guys
been trying to
sign
open it a lot.
Because it's false. Because it's false.
We need to talk. No, I'll tell you why she.
Okay.
You read this?
No, I read the first paragraph.
I'll tell you why I wrote about it.
We are not Friday, right? Because Lady Kelly just sent me an email about the junior high girls working something, and I just before I responded, I didn't double check. Sorry to interrupt.
Yeah.
Sure. Write this down.
Yeah. It's for 18.
Very.
It's a long story.
Alright, so what I was saying is where we are right here. Shh. We've got 2 of them that we're going to have to graph and shade, and then our answers will be where the shading overlaps. Okay, so the
One's a
first.
dark line.
You're exactly right, Landon. Very good. That second one will be a solid curve because it's got the equal bar underneath it. That's what Landon just said. Very good. All right, let's graph the first one first. Y is less than -x squared plus 3. So I'm going to make it be my blue one. We'll do this one in blue. Y is less than -x squared plus 3. Starts off the same. We got to find the vertex. X equals -b over 2a. But this one's easy because what's our b up here where my mouse is?
It's 3.
No.
Zero.
It's 0. Good, Landon.
My A is -1. Shh. I don't have a B. My C is 3. So when I do 0 divided by anything, what do I get? 0. So my axis of symmetry on that first one is going to be at x equals 0, right there on that axis. Okay, now we plug a 0 back in to get our y. When I plug a 0 there, that's nothing, so all that's left is 3. So the vertex for my blue one is at 0, 3. Okay, pick a point. Can't pick 0 this time because I've already got it. So pick another point.
5, -1, 2.
Okay, I'm going to go with -1. I could, 5 would work, Trevor. I just don't feel like counting to 5. I can count to -1. Now plug that in. That'll be negative. Oh, I'm getting ahead of myself. Still got the negative out front, so -1 squared plus 3. -1 squared is 1. Then you make it negative, so -1 plus 3 is 2, which is what Stephen said. So I'll go left 1 and up 2. Then I got to put it in the same spot on the other side. Okay, does this curve get the dashed or the solid line? Curve.
The dash.
Dashed, good.
Oh,
Now I got to pick a test point inside there to see if I shade inside or out. Hey, this is a perfect test point right there, isn't it? So that says, if I plug that in up there, that says 0 is less than 3. True or false?
True, so you would shade
Very
things.
good. So I'll shade on the
Good job,
inside.
Trevor.
Okay, that's half of that chore because I gave us 2 parabolas to graph. So now we got to repeat that process with the second parabola. I'm going to make this one be my red one. Okay, we need to find the axis of symmetry for the red one now. Negative b over 2a. So negative, what's our b?
A B is 2.
2 over 2 times 1. So that's -1, isn't it? Hello?
Yeah.
So I'm going to go left 1. It's hard to read when I scribble all over the place. Left 1. There's my axis of symmetry for this new one. Now I got to plug -1 back into the second one to find my y.
So it's 2 plus 2 minus 3, so it's 0.
Alright, so that, I think Stephen is right there. That's 1. No, it's not. 1 minus 2 minus 3. 1 minus 2 is -1. Minus 3 is -4.
I thought it'd be a problem.
Okay, 1, 1, 2, 3, 4. So there's my vertex for that one down there. Okay, now we pick some other point to plug in. How about 0? If I plug a 0 in here, that's nothing.
0.
That's nothing.
-3.
Left with a -3. So I'm going to go over 0 and down 3.
They have to be on the same on the outside.
Same on the other. Very good. So there's my 3 dots for that parabola. Will this curve be solid or dashed?
Solid.
Good job. So it'll be looking like that. Okay. I can still use 0, 0 again as my test point, can I?
Yeah.
Okay. My mouse just froze. Let me go right up there.
You only recorded this class, or do you record any other class?
I recorded this one for Algebra 2 and 6th period for Algebra 3. I want to plug my 0, 0 in. That gives me 0 is greater than or equal to 0, 0, -3. So what we think here is 0 bigger than -3?
Nope. Yes.
Yes, 0 is bigger than -3. A neutral number is bigger than a negative. So that means this one's getting shaded on the inside also. Okay, so my answer
this beautiful artwork that somebody will buy and hang in their bathroom, is everywhere where the red overlaps the blue. Okay, let's see if we can find where the red overlaps the blue.
Oh, like all in that area.
Yep. That highlighted area would be where they overlap, right?
Yeah.
That's it. That blob is your answer.
You don't have to give out your answer.
No.
Just color in the bottom.
Yep.
Yep.
Yep. What kind of shade?
Ugly stuff.
How many of those are going to be on the test?
I don't even know yet, Stephen.
Never learned to lie.
What's so funny about one?
Alright, I want to take us back to actual algebra instead of graphing where we saw something algebraically.
Where is it?
Yeah.
I can't remember what it's like that I did.
Alright, we got x squared minus 3x minus 4 is less than 0. Y'all pay attention. I told you our directions were going to change. Those first few problems that we worked, the directions said graph. This time, the directions say to solve. Okay? So what we're going to do on this, first off, it's got a less than sign. We're going to initially not worry about that and just solve it like it's a normal quadratic with an equal sign. Which means you can quadratic formula, completing the square, factoring, any of those methods that we've been using that you like. Okay, I'm going to check and see if I can factor it real fast. A times C is negative 4. Factors negative 4 that add to negative 3. Negative 4 and 1. So it's going to be real fast to factor. If you want the quadratic formula, go ahead and do it. I've got x minus 4 times x plus 1 is equal to 0. Set both of those equal to 0 and solve. So x is 4 and x is negative 1. Okay? That's old. We've been doing that for a couple of weeks now. But what we run into, since it's got the inequality sign, okay, if we think about what these would look like on a number line, if we find negative 1 and 4 on a number line, this sign is going to tell you a whole heck of a lot. And this is the way we do this a lot in Algebra 3, and this is the way I told them to remember. If it's a less than sign, the conjunction word is going to be and. What all this means is that your shading is going to be on the inside. If it's a greater than, it's going to be or, which means your shadings are going to go outer. Stephen.
I did something wrong. But I don't know.
Okay, I'll have to look at that a second.
You did something wrong, Steve.
So less than, the way we remember that, less than rhymes with and. So when it's and, that means the shading goes in the middle. So my answers to this would be anything between negative 1 and 4. Okay? So to write our answers on this, now to write that mathematically, if my answers can be anything between negative 1 and 4, that's where your variable goes. So it would have to be bigger than negative 1 and smaller than 4. That's the way you would see the answer on that.
Have we done this before?
Yeah.
We have.
What did you think you did wrong? What's 3 plus 5?
I know, but like, I still have the divided thing.
What's 3 plus 5? Divided by 2. That's what I got.
Oh, okay. Yeah, I didn't know if you were supposed us to divide those, or do you like that?
You simplify it when you can.
You're distracted. Hey,
I need new straps.
hey, what that last thing say those
But
are?
I want
Know your form.
you to go take these straps and get some new straps.
Well, you can actually like.
It's on the board over
there.
Yeah,
Yeah,
now it
but
is.
I'm gonna replace one with the whole new pair because mine has insurance.
Alright, we got 3x squared minus x minus 5 is greater than or equal to 0. Okay, so I'm doing the directions say solve, so the same directions as the last problem. So I'm doing a real quick check, and I know I can't factor. Because a times c is negative 15. There aren't any factors of negative 15 that add to negative 1. So I can't factor, so I'm with you on the quadratic formula. So I'm going to have my a is 3, my b is negative 1, and my c is negative 5. So I got negative b plus or minus the square root of b squared minus 4ac all over 2a.
Now, 4 times 3.
End up with 61.
Are you good on that? Underneath the radical, Stephen's correct.
Where is it?
61.
Yep, he's right. Yeah,
Get
Steven.
that, Jody? You're looking at me funny.
No, I'm just trying to
Five,
breathe at
Steven.
the same time.
Yeah, gotcha. So I got 1 plus or minus the square root of 61 over 6. Alright, 61 is not a perfect square. It's not on my list over here. Do any of these perfect squares go evenly into 61?
8 almost does, but.
That 8's not a perfect square.
8 almost does.
And it's not a perfect square. Shh. Does 49 go evenly into it? No.
No.
36? No. None of those go evenly into 61, so it won't break down. Okay? So that means my 2, because this has got 2 answers, my 2 answers are 1 plus whatever the square root of 61 divided by 6 is, or, because it's greater, remember I said greater means or 1 minus whatever the square root of 61 divided by 6 is. Now this is a time when it's actually okay to get a decimal on some of this stuff. I'm going to go ahead and, what is the square root of 61, like 7 point what?
7.81.
Okay, so do 1 plus that. Give me some numbers here.
4.
8.81 for the 1 plus the square root.
Did you divide by 6 yet?
And then divide that by 6 and you get 1.47.
Okay, 1.47, and what's my other one?
And then 1 minus 7.84 equals, divide that by 6, you get negative 1.14.
Alright, so what we have here to write our answers on this, x, this one's obviously your smaller one, right? I told you that the ors, if we look at these on a number line, on the and, back up here, on the and it was the middle, the ors it goes outside. Okay, so if I put that same concept here on this number line, here would be my negative 1.14. So if I'm looking at outside, it would go that way, 1.47. So I would say x has to be less than or equal to negative 1.14, or,
Coach Wright.
yes,
Hi, can you have Lee that calls come to the office after class?
yes,
Thank you.
and that would be it.
You're in trouble,
It's not.
What's that for? Is that 1.14?
Negative, yeah, negative 1.14. All right, listen real quick, and then I'll give you a couple of minutes to digest here in just a second. The majority, the main importance of this unit that we've been doing is solving quadratics. Okay? These last couple of things that we looked at yesterday and today, yeah, they're important, but not as important as solving the quadratics. That's what we got to make sure that we're able to do. That's what we had a couple of assignments over at the end of the week last week. we're going to have some more assignments over that coming up this week, okay, to make sure we can solve them, whether it's factoring, quadratic formula, whatever method you choose. That's what the main importance is. Yeah, you might see one or so of these on a test, but not very many. So we're going to go back and revisit over the main importance of the solving quadratics. Okay? Very good? All right, so we're going to stop it right there for today.
Woohoo!
Landon just played.
Coach Ray,
Yes, ma'am.
what